Welcome to this live webinar, Smart Headlamps, Lighting and Sensors. I'm Cédric Bélanger, Product Marketing Manager at ANSYS. We deliver this webinar in live and direct, so don't miss the opportunity to interact with us. I invite you to connect to Bcast using your smartphone, preferably, but you can open it on your computer too, on a second window. I have the chance to have the support of Thomas Lejeune.
Hello Cedric, hello everybody. So to connect to Bcast is very easy. You just need to flash the QR code, or you can also just enter in your navigator bcast.com/ANSYS, and then please connect it. You will interact with us, so you can at any time ask your question, take part into the polls, the word cloud, and you will at the end be able to download the PDF of the presentation. So I will put it at the end. I will let the first activities begin.
Yeah. The first question: what does smart mean for you? What are the keywords associated to smart? So you can already start to when you're connected to answer this question, and we will have the question
with the intention
at the end of the webinar.
Thank you very much.
Thank you, Thomas.
Enjoy the webinar.
Please welcome Julien Muller.
Hi Cédric.
Hi Julien.
Hello everyone.
So today I'm very pleased to host Julien Muller, product manager and expert in automotive exterior lighting. First, a few words about Optis. Recently affiliate with ANSYS. Optis is a world-leading company in virtual prototyping, provides simulation software allowing you to accurately simulate the performances of light, human and sensor vision, and material interaction, ultimately allowing you to experience your product virtually before ever spending the time and money to build multiple physical prototypes. So thanks to Optis, you can imagine, design and experience, virtually see what you will get during all stages of the design, engineering and manufacturing process. Automotive innovation has been a passion and the main industry focus for Optis for more than 25 years. The changing landscape of headlamp technology at the dawn of autonomous driving has made automotive an even more interesting topic today. So maybe we have the result of the. Okay, so the first words are coming on the word cloud. So intelligent, lighting, sensors. What does smart headlamp means for you, Julien?
So, smart. You're smart, Cédric. Huh? Everyone, you know that. But what is a smart headlamp? So, a smart headlamp in our approach will consist mainly on three topics that we'll cover today. So first, we'll discuss about the signature of the headlamps. So we'll discuss briefly on one aspect, which is the signature. So we'll discuss about light guides. You will see that later. Then we'll discuss about digital lighting, because of course you know that AGB is a new trend, so we have a glare-free I-beam, which is definitely the next step. And finally, thanks to autonomous driving, so you know the ADS, automated driving system, is definitely the next trend for the coming years, but lighting will be still there. So the headlamps will have to be smart with sensor integration or something else. We'll discuss that later.
Okay, so signature, the first challenge. Let's start with the first poll. What is the most challenging when designing a light guide? You have 4 proposals: respect time constraints, reach quality, homogeneity in color and intensity, choose the right material, define LED flux. So you have 7 points to allocate. The more challenging, the more points you assign. So you can let a proposal to 0 if it's not challenging compared to the others. While you answer, Julien, what is the technology of choice to work on the lit signature of a headlamp?
So first, let's discuss about what is a light guide. So why light guide? So light guide is definitely a trend. As you can see, it's really thin, so you can have a perfect signature for your car. You can highlight the headlamp signature, the appearance, so you can create something really interesting for your car signature. It's homogeneous, so you don't have pixel effect, and yeah, it's really creating your signature. So it's quite challenging, of course. And so what is the result? So yeah, basically people are challenging with the time constraints. And
maybe we can display the result of the polls, the first result. So what is the most challenging? First, respect the time constraints,
yeah,
reach quality, homogeneity in color
yeah,
and intensity,
yeah.
and the define LED flux.
Yeah, of course, as well. Yeah. So not so easy to manage. Yeah, time seems to be quite challenging. Yeah. So we have a solution in Speos to design light guide. So this is just a brief overview we have today. So this is just different aspects we have in our product. In the light guide parameters, we can control the different parameters, to control the light direction, to send the light direction in the right direction where you are looking at the light guide. Of course, it's a headlamp, so you need to pass a regulation. So we can simulate the intensity, we can check that the daytime morning lamp, for example, is passed. But the key point, as I mentioned before, and yeah, as mentioned by our customers, is definitely the lit appearance. So for the first iteration, for the first design, you can see that the lit appearance is not so bad. But if we are really paying attention to the luminance value, if we're doing a cross-section, you can see that it's decreasing. So it's not really what we expect for high quality. And so we have
acceptable, but
not the state of the art, and we can go further. So we have done some measurements. We have highlighted the RMS contrast, which is 1.6, which is, yeah, as I mentioned, not so good. But this is just the first try. Just you launch it. 30 minutes later, you get that result. So not so bad. But we have something more, something better, even better, which is optimization, automatic optimization. So automatic optimization is in optimizing automatically using our own algorithm another parameter, a parameter which is controlling the efficiency of each prism. So each prism is locally adjusted to reduce the quantity of light we have at the beginning of the light guide and add more light at the end. So you can see that the luminance is better, is flatter. So you can see before it was decreasing and now it's flat. And you can see that the RMS contrast is 0.18, which is definitely better. We still pass the regulation, of course. And the key points, you will say, how long does it take for that? Just a night. Just a night. So you start your first iteration just before leaving, you launch the optimization, you arrive on the morning, you get that result. Quite impressive. You want to see it?
Yes, let's jump to the demo. Just before you start the demo, maybe we can connect, for those who don't know already, the link to Bcast. Maybe you can display the link bcast.com/ANSYS, just to be able to answer the polls and to chat with us.
So let's start the demo.
Let's start the demo on the light guide.
Okay, so this is my car project. We don't care about the cars, and in that case it's a Tesla, but okay, we don't care, I say. So I will just focus on one light guide. So how complex it is to create a light guide. So to create a light guide, as we are integrating into CATIA V5, and we have this curve, for example, for coming from the design department, I will just create a light guide using our specific optical shape features, and one is dedicated for light guide. So first, I just need to select the guide curve, which is this curve here. And the light direction will be like this, so I will put the LED on the outside here. And then I will select the light direction, so my optical axis. And so that's it. I just select my two inputs. I have some prism parameters, so I will adjust automatic because this is my first try. I don't know how to control that. And just for the test today, I will just put 2 millimeters and adjust these parameters as well. And that's it. I just launch the construction. It takes a few seconds. And after the construction, I will pay attention to the detailed design. So during that time, the light guide is built with some prism behind. Okay, done. So you can see that now we have a geometry with some prism behind. So if I'm just adding the different inputs, you can see that some prism have been created, and depending of the light direction, the angle is changing so along the light guide. So this is the first try. So after our first simulation, we could get a simulation result. So let's open it. This is I already ran the simulation because we don't have 30 minutes today.
And it takes 30 minutes.
Yeah, or even less, actually. To be honest, to tell you the truth, it just takes 8 minutes on my computer, so it's quite short. And this is what we can get initially. And you can see that I have my RMS contrast as 1.6, as I mentioned before. And you can see that the luminance is decreasing, so which is not so good, let's say. Not so bad, but not so good. And here we have an optimization feature that I have already set. And so I have already set some variables. So meaning that these variables can be adjusted automatically. And I can target to reduce the RMS contrast of my signal. So the point is, after the optimization, so it has run last night. And after the simulation, this is what I can get. So simulation has been run. Maybe this one has run slightly longer because I want to have a better resolution, and so I run it on HPC. I will discuss that later.
Okay.
And the point is definitely this one is much better. As you can see, it's flat, and the RMS contrast is definitely good. So this is just a sneak peek on our light guide feature, on our OSD feature. As you have seen in our toolbar, we have much more functions like a reflector, optical lens, so all the optical function can be done with OSD. So
okay, so coming back to the challenges after the signature, we will consider the second challenge. Okay, the second challenge is digital lighting.
yeah.
So let's continue with the poll. What is the most challenging today in digital lighting development? So you can answer this on the bcast. Can you display the, So you have 4 proposals and 10 points to allocate. The more challenging, the more points you assign, and you can let a proposal to 0 if it's not challenging compared to the others. So the proposal, well, I'll let you answer the poll. While you answer, we will continue with Julien. So Julien, what is digital lighting and what is decisive in development?
So, well, we have discussed about lighting, optical concept, optical design already. So of course it's a key point. But when we are discussing about digital lighting, this is not only the only point. If you are considering Günther Fischer, which is working at Daimler, according to him, the decisive factor is not only the lighting, it's also the system, it's also the intelligence you are putting on the car, the way you are controlling the headlamp. So this is a digital intelligence. So you need to have a good optical system, of course, to have homogeneous beam pattern, but you need also to have a smart control load to control precisely the light on the road. So you can picture your beam, but you need to have good appearance for your customer to be satisfied with what they can see on the road, and for them to understand also what they can see on the road. Okay. So definitely the software is a key point. So let's discuss about our solution. So our solution is based on a mix between real-time solution and SPEOS simulation. So first, the ideation. So when you have an idea, when you want to display, for example, let's say, does it make sense to display a crosswalk on the road? That could be your question. Does it make sense? We can test that.
The communication to pedestrians.
Yeah, maybe for them to understand that. Yeah. Does it make sense? What is the number of pixels you need? Okay, this TV is maybe 4K. Does it make sense? Yes or no? It depends of your usage. But in case of digital lighting, it depends of your application. If you just want to avoid a glare-free I-beam or to display a crosswalk, you don't need the same number of pixels. So again, at the early stage, you can define the resolution you need. Then when you define that and you want to go deeper in the design, you can go back to SPEOS and optical shape design to define precisely the lens system, the DMD solution or DLP. It depends of your concept. so you can have really the optimum optical design fitting with optical targets. But as I mentioned before, software is the key. So you need to have system control law. You need to be able to simulate the control law. So this control law definition is not done into SPEOs or their experience, is done into the customer software. So they can use any solutions that they are using usually. It can be MATLAB Simulink, it can be SCADE, it can be any tool. Any FMI standards can be used. And then the point is, we'll see that later in our demonstration, we can test and validate the control law in live, so in real time, like a real night test. Instead of spending your night to drive, you can just drive here at the office during the working hours.
Experience a complex scenario.
Exactly, yeah, exactly. And so finally, also, you can also promote the technology thanks to some video recording, and you can diffuse that concept on your website, on your car store, so you can promote your technology to your final customer. So quite interesting.
So before you explain in detail, I just want to give you the result of the poll.
Yeah.
So it's quite clear that optical design is a challenge in digital light development. The control law adjustment also, and the complex scenario test and validation. These are the three main points, the three first points. But it's quite balanced.
Interesting.
And I think everything is challenging.
Okay, interesting.
If we look at this,
So, okay, let's consider first the central part, which is Their Experience. Their Experience, it's our real-time solution to drive a car, like a virtual car. So this is a driving simulator. And on this driving simulator, we can add headlamps, matrix beam, pixel beam, intelligent lighting. And the key point here, we have the human vision, because we are expert on that part. So we have some measurement to assess and measure the glare generated by your headlamps. We are discussing about glare-free I-beam, and we have a solution to measure the glare. So that's the key point. The inputs, where does it come from? Of course, from SPEOs, because in SPEOs we can simulate precisely your design, your beam distribution. It can be other software, but SPEOs is definitely makes sense, especially if you want to pay attention to the color variation of your beam pattern, for example. And on the other part, to control the sensors, the camera, for example, you can use, let's say, Simulink in that case. And in Simulink, you can have camera inputs and an output to control the headlamps, to define which pixels have to switch on and off. And in that case, automatically, it's controlling the headlamps.
Okay.
So let's
jump to the demo.
Yeah. So please take a seat. And so this is our short, small driving buck. And here I will just activate the automatic driving for you. So you are not really driving. It's a joke. You can see maybe it's good driver, but actually it's automatic driving.
You have to change the panel to 90.
Yeah.
Will be 80 in a few
days.
Sure.
So the point again is not to focus on driving experience here. It's more to focus on the headlamps performance. So we have some tools to assess the lighting. So we can display the aiming wall to see your beam pattern. But the key point here is there is a car in front of you, and maybe you are in full high beam. So usually what you will do in that case, you will switch to low beam. But if you are switching to low beam, you will lose some visibility range. So the key point is to switch to high beam, but activate the glare-free I-beam. So the first solution of glare-free I-beam is matrix beam. So if I show you the aiming wall, you understand how does it work. So the idea is just to switch on and off some LEDs. And so you can see that in live. And you can see, in that case here we have also the adjustment, automatic adjustment. So I can change anything I want on my software.
Okay, you can test. Yeah.
For example, I can deactivate the adjustment of the cutoff.
Okay.
I can activate some bending lights effect to follow you. There you can see that this car is in high beam and it's glaring you.
It's glaring.
Yeah. And what else? We can activate also the pixel beam. So what is pixel beam? It's quite impressive. I will just activate you the aiming wall again.
Yep.
I will slightly change the distance, for you to understand it. And now I will switch to pixel beam. So just for you to understand the difference, I will just put the scenario in pause. So you can see that in that case, you are creating a shadow area, which is quite large around the car. And thanks to pixel beam, actually, we can just put a shadow just on the car. So you have more lights on the road. You can align with the pedestrian. Yeah. So this is quite impressive. This is the pixel beam solution. So you see the pedestrian, you see maybe some animals coming, so you are safe. Of course, it's automatic driving, so you don't have to pay attention. All your car is driving automatically, is controlling automatically your headlamps. You are still driving, but your headlamps is controlled automatically.
Yeah.
There is a pedestrian here. How about if, my first question, or your first question, how about if we are displaying a crosswalk? So just consider, for example, there is a pedestrian close to the road, and our first ID. We want to test. How about if we are putting a crosswalk?
The information that he can cross the road safely.
Exactly. So thanks to the lighting, we can put a crosswalk in front of him. So does he understand the message? I'm not so sure. You are in the middle of nowhere. You are just putting this kind of message.
Does it make sense? Yeah.
Does it make sense?
It's a way to communicate vehicle to pedestrian.
We can discuss. Maybe we can discuss with your manager. Yeah. So here you have a tool. Okay. You can discuss that. You don't need to experience. You don't need to go on the real night test. You can just discuss around the screen. You can have a meeting with different team members, and this is a tool to discuss and decide about the next generation of cars. So yeah, quite interesting. We can test many things of this software as well. So changing the behavior of the dimming up speed, and many things. Really interesting software.
I think we are getting closer to our last challenge.
Yep.
After the digital lighting, the autonomous driving. We'll start with the poll. So innovation for the headlamps aim at improving the perception of the environment at night for the driver, but also for the vehicle itself when in autonomous mode. So what is autonomous driving for you? This is a revolution. Give us some keywords on BCAST associated to autonomous driving, and Julien will give us his feeling on the autonomous driving, the revolution of the autonomous driving.
So is it a revolution?
During this time?
Yeah, maybe my dog can drive this car. Maybe not today, I would say. Okay, of course, it's definitely a must. This is a dream. When I was young, I was dreaming about that autonomous car. Like you are sitting, you put your undress, and you're just sleeping in your car, and you wake up, you arrived. That's definitely a dream for safety, for time, for mobility. You can really optimize your life. But okay, maybe you know that some cars are already driving automatically.
We heard
but
that, we have the feeling that maybe 90% is done.
Yeah, but maybe 90% is still remaining to do.
Okay.
That's
the famous rule: 90% done, but 90% left to go.
Yeah. So definitely, actually, in the standard cases, in the generic cases, it works. But if you are considering the weather, if you are considering the sun, if you are considering the fog, if you are considering the rain on your sensors, all these things can disturb your sensors. So there is some numbers to say that you need to drive 4 million kilometers or miles, but at the end, does it make sense to drive during 300 years?
300 years.
I'm not so sure.
Life.
So you have to use a virtual simulation. This is the only point. So you need to have virtual testing, and you need to have a physics-based solution. Because here we don't want something just approximated. We want to simulate the rain, we want to simulate the sun, we want to simulate the fog. So concerning the sensor physics characteristics. So this is why Optis, ANSYS, Speos make sense, and Verix as well.
Yeah.
So first, the light source. We have a perfect model to model the luminaire from the street lighting. The headlamps, we have just seen that before. The sun, which is a key point of Speos that we can implement in real time as well. For the light sensor, of course, we are really strong in the human vision. But in case of light sensors on automotive car, this is cameras, lidars. So let's consider this one first. we are also good knowledge on these sensors. And the last point, which is not the least, is the material properties. As you know, this table is reflecting the road, but not exactly in the same way than this surface. So depending of the different surface and depending of the wavelengths, because for the LiDAR, the wavelength is not exactly the same. So we need to have a perfect characterization of those materials. And they need to work together. So this is what we are proposing in our solution. So accuracy, a predictive design, huge realism. So you can trust your simulation. You can change just one parameter here, and you will see the effect on the sensor. You will see the effect on this system. So how your car will react.
Yeah, the reliability in the system, in the simulation, is really key.
Yeah, that's a key point. You need to have a predictive simulation. And so, by the way, validation predictive.
The keywords, the keywords, we can display the keywords associated to autonomous driving. So, yeah.
Virtual map, interesting. Radar, radar, we'll discuss that later. Interesting.
Image processing. Yeah.
So, first point, we have, basically, as I already mentioned, we have two main products. First, PEOS, which is our historical product for light and optical sensors. It's accurate, it's physics-based, it's precise, and it's proven. But it's more for open loop simulation because it takes some time. Of course, you can use HPC to decrease your simulation time, but it will take some time to define a perfect simulation. So it's not really closed loop approach. And we have their experience, which is definitely our real-time platform that we have seen before. This platform is definitely for the ADS application. It's real-time physics-based engine, so you can trust it. You can do mill, seal, heal. So hardware in the loop testing can be done with their experience. So that's the key application for ADS. So now let's discuss about the two main sensors.
Two main sensors
so
we have.
Maybe
today.
radar is missing, but
Yeah.
as you can see, just at the bottom, ANSYS is coming. So the radar will come with ANSYS software, which is already there for a while. So today we just discussed about camera and LiDAR. And first we'll discuss about the camera. So in PEOS we have already the possibility to simulate precisely the camera. So we can detect the worst case sequence. So we can detect some stray light. We can do some stray light analysis to detect some hotspot or we can optimize the baffle to cut some stray light or something else. We can choose the right position for the camera implementation. So we can define the field of view of the camera. We can define the best position of the camera. So this is, I would say, the static approach. And of course, we can go to the real-time solution with some image processing. So for example, here it's a lane detection. So we can simulate with a scene coming in front of you. You can simulate the camera. And we can do some image processing, for example, in that case, the lane marking. So that's quite impressive, and we'll see that later in live. So the second,
quickly because
So the key point is really to have the closed loop approach to come back to the matrix beam, for example, or for something else. So to discuss again about the LiDAR, not again, but to discuss about the LiDAR, the first solution we have is to have a precise simulation with PEOS. To simulate what is inside the LiDAR, so which is quite useful for the LiDAR maker, and you can optimize your definition. The second point is to place the LiDAR. Does it make sense to put the LiDAR inside the headlamps? Yes, it makes sense. There is some space, probably, but maybe you want to hide the LiDAR. So you want to put it back on the headlamps. But if you are putting back, you will cut the beam pattern. You will cut the image seen by the LiDAR. But if we are paying attention to the lit appearance, which is the opposite point, we can see that in the back position we cannot see it, and in front position we can see it. So it depends of what you want to have on your technology. And finally,
you need to try
the driving condition scenario. So let's consider one scenario like this. So you are crossing. You want to change your way. And a motorbike is coming close to you. So if you didn't pay attention to your blind area, you will hurt it. So how to avoid that? Let's go to the demo.
Okay.
So in that case, we have a demo which is already set. And what you can see, you are not driving because we are paying attention to automatic driving. So the point here is not to drive, but is to test your driving vision. So this is your camera vision, which is this sensor here, the yellow one, which is a forward camera. And you can see that it's some saturation, so you can adjust some parameters, some distortion can be considered. And this image can be post-processed to do some analysis, as we have seen before. This one is a Velodyne rotating LiDAR, which is positioned here at 360 degrees on the top of the car. So you can see what is seen by the LiDAR. In that case, there is almost nothing. Yeah, just some entrance of the tunnel, so not so interesting in that part. And this one are left scanning LiDAR and right scanning LiDAR, which are on the side. And maybe not so
dedicated to the blind spot.
Yeah, exactly. So
okay.
In that case, you can see, for example, a motorbike coming here, so to avoid what we have seen before.
Yeah.
So that's the LiDAR solution. We can change the point of view here if needed, but I mean, for the LiDAR, it's 360, so we can see.
You can see the car.
Yeah, you can see that car,
which
is
the LiDAR is detecting the car.
Exactly.
Okay.
Perfect.
Yeah.
Good. So yeah, that's our solution. So let's try it. So
okay, thanks for this this demo. So I think we have to maybe you have the associated word to autonomous driving. You speak about virtual map, LiDAR, radar is coming. So it's important because I think we will close on that. Today we have camera and LiDAR, and with the association with ANSYS, we will have the radar. Yep. But first, just a takeaway on the different points. Yeah. Let's start with the smart design.
So our discussion today was about smart headlamps. So smart design first. So we discussed about light guide. We say ready from the first iteration, but it's even better after optimization. So this is the first smart design. Then smart lighting. We discussed about digital lighting. So you can test your ideas. You can test any technology, micro AFS, DMD, LCD, MEMS can be evaluated in their experience. And smart headlamp with sensor integration, camera and LiDAR first. But as I mentioned, ANSYS will bring the radar to our offer. So we can have some parametric scenario, as I mentioned, so you can change some parameters like weather or sun position to test your ADS. That's it?
Yeah, so that's time for the question and answer. Maybe the future, and we will launch also the last polls. Thanks to our solution, how do you imagine the future of automotive lighting? So you have discovered that we are able to work on the smart design, on the smart lighting, and on the smart headlamp at the dawn of autonomous driving. So thanks to our solution, what you will bring in the future of automotive lighting using our solution? While you are writing some keywords, I see first fast, product life, stronger, human-centric. Human-centric is very important. If you have some question and answers, it's time. No, question. We will have the answers. It's time for you to ask your questions. Maybe Thomas, we have one question.
So the first question is, can you only simulate the FOV, or can you simulate the optical properties of the headlights lens on the LiDAR?
Yes, this can
field of view. Or Can you just repeat the question?
Yeah. So can we simulate the FOV, field of view of the lens distortion of the LiDAR? So first, yes, the camera we can do that. It's already proven, and we have already done that. For the LiDAR, this is coming in the next release. We are already working on that. It's under development, and I've not shown that in the demo, but we have some possibility to change the parameters of the different sensors. So we can change the resolution, the field of view, the distortion coming from the lens, or even from the imager, on the imager. So yeah, it's quite interesting topic because you want to test, to stress your sensor. So yeah.
Okay. Another question, maybe? Thomas? Well, I think it was the first time we were using the Bcast chat and polls solution. I think it's quite interesting. We need you to be connected. So thank you very much for attending this webinar. We are not on time, but I think you have discovered a lot of interesting topics and information. So please contact us to know more, and stay tuned for the next webinar.
Thank you, Cedric.
Thank you, Julien.
Thank you.